Hello, everybody. Welcome to the second session of this afternoon. I am so excited to introduce to you Mina Cho, because she is from the Carlson School of Management, my alma mater, although I understand there's been a rebrand recently, so it's going by a different moniker these days. But what we're going to do is we're going to have about 30 minutes for a presentation, and I'm going to ask you to save your questions for after the presentation, and we'll have about 10 minutes to do questions. So without further ado, here is Mina.
Hi, thank you so much. My name is Mina Cho, and I am a PhD student here at the Carlson School of Management at the University of Minnesota. I am in the Information and Decision Sciences Department, and this is a joint project with my professors Mo-Chin Yang and Alok Gupta. So before getting into the details of this project, let me actually motivate my study by talking about two types of knowledge. So firstly, we have explicit knowledge, which is the know what that can be codified into formal language. So this is the type of knowledge that we can write down into words. Now think of the written exam part of your driver's license exam. And the second type of knowledge is tacit knowledge. So this refers to the know-how that is often difficult to articulate in words. Now, this knowledge is only gained through experience and practice. Now, think of the road test part of your driver's license. So in organizations, both types of knowledge are important, but for the purposes of this presentation, I would like to focus on tacit knowledge. So in organizations, seasoned professionals have tacit knowledge, which they have gained through numerous years of experience and practice. And when they leave the organization, whether that's through retirement or changing their positions, they take that tacit knowledge with them. And this is problematic for the organization because it's important to share that knowledge within organizations and keep it within the organization. So it is with this backdrop that our study tries to see whether we can use LLMs to help this challenge. So we would like to point out that tacit knowledge is notoriously difficult to externalize and transfer. And let me define externalization in just a second. So tacit knowledge, as I mentioned, because it's so deeply embedded in people's experiences and contexts, it's difficult to externalize, or in other words, to transform that tacit knowledge into an explicit form that can be written down and transferred to other people. Hence, this challenge is nicely summarized by what's called Polanyi's paradox. So Polanyi's paradox says, experts know more than they can tell. So in other words, experts know how to do things, but they might have trouble articulating why they do or what they do, right? So it is with this challenge that we ask, can LLMs come into the picture to help solve this problem? And we think that LLMs might be a potential solution to this knowledge externalization problem because of the characteristics of the large language model. So LLMs, as I'm sure all of you know from today's talks, can process large amounts of data to identify latent patterns and generate outputs in natural language, right? So LLMs might be a solution to help codify this tacit knowledge into words and help us transfer that knowledge from experts to novices within organizations. So before diving into whether LLMs can help this challenge, let's actually take a look at what have been traditional approaches to knowledge transfer. So traditionally, methods such as mentoring, coaching, and apprenticeship have been used to transfer knowledge within organizations. And this is when novices actually interact with the experts and learn that tacit knowledge. Another form of transfer has been through interviews, where the interviewer tries to elicit that tacit knowledge and capture the reasoning behind experts' decisions. However, we must note that these methods are resource intensive because you must take experts out from their daily work and help them mentor, coach, and interview their tacit knowledge. So this is problematic because it's constrained by the availability of the experts, hence difficult to scale. So with these problems, in comes the large language model, and let's see if LLMs can actually help solve this challenge. So to state our research question more formally, we're trying to understand whether LLMs can be used to externalize tacit knowledge and help the transfer from experts to novices. And we explore this question in the research context of online math tutoring. So we leverage a data set that has been made public by Wang et al. 2023. And in this data set, it contains conversations between math students and math tutors. And specifically, these conversations focus on parts where the students make a math mistake and where the tutor responds to that mistake. So let me actually give you an example of a conversation. So one example of a conversation is when the tutor says, "Any questions so far, student?" to which the student answers no. Then the tutor asks, "Mike has 4 cookies and he eats 3. So Mike has blank cookies left." And the student makes a mistake by saying he has 10 cookies left. Now, in this data set, we have access to 2 types of tutor responses. The first type is the novice tutor's response. For this specific conversation, the tutor said, "Well, that was a good try, plus 1 point for your responses." But then we have access to experts' tutor responses as well. And here the expert tutor said, "Great try, let's try to draw a picture. Let's start with 4 cookies and erase the 3 that Mike eats." So we have about 700 of these conversations where the student makes a mistake, the novice tutor responds, and then the expert tutor responds to the same question. And another unique thing about this data set was that the authors interviewed expert math teachers and tried to capture the reasoning behind their responses to the students' mistakes. So the authors came up with these 3 steps after interviewing the expert math teachers. So the expert math teacher said when they form a response to students' mistakes, first of all, they try to infer the type of error. So did the student guess the question? Did they misinterpret the question, etc., right? And then they said they go through step B, they determine a strategy they're going to use through their responses. For example, do they want to explain a concept? Do they want to ask a question, etc.? And finally, they identify the intention behind the strategy. For example, through their response, do they want to motivate the student or get the student to elaborate their answer, etc.? So for the purposes of our research, the tacit knowledge is this reasoning that goes in the experts' minds when they try to formulate a response to a student's mistake. And throughout the presentation, I am going to refer to these 3 tacit knowledge as the human best effort benchmark. And this refers to the fact that this is the best tacit knowledge that human experts themselves could articulate in words. Now, with this backdrop, we present our first research question. Can large language models effectively externalize expert tacit knowledge, and how to do so? So looking at the flowchart, we're interested in whether we can go from experts' actions and their decisions to some kind of tacit knowledge representation with the help of LLMs. And our specific method is we use different prompting strategies to externalize knowledge. And we use a 2x2 design to manipulate 2 things while externalizing this knowledge. So first of all, we manipulate whether or not we provide conversation data. And second, whether or not we put a restriction on the output structure. And by output structure, we mean, do we ask the model to output the tacit knowledge in 3 steps? Or do we let it think in free form and come up with how many steps as it wants to? So looking at this 2x2 table, the LLM baseline is when we ask the model to extract the expert's thinking process without any conversation data provided, so just relying on its base training knowledge, and when we do not provide any structural constraints. So we're letting it think in how many steps it wants to. For the LLM plus conversation condition, we do provide the conversation data, but do not put any restrictions on the structure. For the LLM plus structure condition, we do not provide conversation data. However, we ask the model to limit the thinking and come up with 3 steps as a form of tacit knowledge representation. And for the LLM plus both condition, we do provide the conversation as well as putting limitations on the output structure. And for each of these 4 variants, we externalize knowledge 10 times using ChatGPT 4o with a temperature of 0 to minimize any stochastic variation. Now that was pretty high level. Now let's actually take a look at what prompts we used. So these are the prompts for the 2 conditions where we do not provide any conversation data. And commonly across the 2 conditions, we tell the model, hey, math teachers are experts who have tacit knowledge. And one of this tacit knowledge is the thinking process behind a response. And for the LLM baseline condition, we tell the model, please organize experts' thinking process into step-by-step decisions without restricting the output format. So we're letting it think in how many steps it wants to. For the LLM plus structure condition, exact same thing, but we tell the model, come up with 3 steps for the expert's tacit knowledge. For the 2 conditions where we do provide the conversation, we provide a file with 480 conversation data between students and tutors and tell the model, hey, this file contains conversations between a tutor and a student about a math problem. Look at the conversation and organize their thinking process into free form step-by-step or in 3 steps. So let's actually take a look at one of the outputs the model produced when we externalize knowledge using these prompts. So this is an example of the LLM plus conversation condition. So as a reminder, it's when we did provide the conversation, however, did not restrict output in any form. So you can see that the model thought that looking at the conversations, we think the experts went through 8 steps in coming up with responses to students' mistakes. Now, how do we evaluate whether this form of tacit knowledge representation is good or not? We do that by comparing the similarity with the human best effort benchmark that I mentioned earlier. So it's the human articulated tacit knowledge. And how we do that is we compute the cosine similarity scores between the 2. So we take the LLM-externalized knowledge, for example, this one, and then we have the human best effort benchmark and compare the similarity scores between these 2. And let me actually present some results. So this is the cosine similarity scores across the 4 variations on the x-axis and the average similarity on the y-axis. The score ranges from 0 to 1, 1 being the more similar. And an interesting thing we found was that providing the conversations when externalizing the knowledge significantly decreased similarity with the human best effort benchmark. So going from the first bar to the second bar, and the second bar and the third bar to the fourth bar, everything else is the same except whether or not we provide the conversation data. The second interesting result we found was that putting these structural constraints when externalizing the knowledge against significantly decreased similarity. So when we let the model think in free form, it came up with a knowledge representation that was more similar to the human articulated knowledge. What does all this mean? Let's talk about some implications of this finding. So we can see that showing the model what experts do in terms of their conversation data decreased the similarity with what experts say they do, the expert's self-explanation or the human best effort benchmark. And this is, in line with Polanyi's paradox that I mentioned earlier. Experts know more than they can tell, because it shows that experts' self-explanations might not be fully reflecting their actions. Now, with this result, we ask our second research question: can LLMs use this externalized tacit knowledge in making effective decisions? So we're interested in going from the externalized knowledge from the first research question and helping models behave in a certain way to reflect better quality decisions. And again, let's take a look at the prompt that we used to understand this question. So again, we used the externalized knowledge from the first research question and put that into the model again and asked the model to generate responses to students' mistakes. So this is the prompt that we used for all 4 variations. We told the model that you're going to be given a conversation between a student and a novice tutor, and the conversation ends with a mistake by a student. Below is the tacit knowledge that expert math teachers use to determine their responses to the student's mistake. And in this yellow bracket, we input the different externalized knowledge that we got from the first research question. And then we instruct the model: imagine you're an expert math teacher conversing with the student. How would you respond to the student's mistake? So just stepping back, we're trying to help the model use different forms of tacit knowledge and help them generate responses. And we're trying to see whether the different forms of tacit knowledge leads to different quality responses. And we use the 4 versions of tacit knowledge extracted from the first research question, so the 2x2 condition. But we also add a 5th condition. So it's the human best effort benchmark condition. So we input the 3 steps, the human articulated knowledge that I showed you from Wang and L's original paper, and tell the model use this knowledge to generate responses. So in total, we're comparing 5 LLM-generated responses. And you might be wondering, hey, does the different forms of tacit knowledge actually make a difference in the responses it generates? So this is an example of responses generated for one conversation. And as you can see, just by eyeballing it, the different conditions leads to different responses in terms of their length as well as their content. And how do we measure whether the responses are good quality responses or bad quality responses? We measure their pedagogical value. So we measure how pedagogically valuable is the response. And we turn to education literature to come up with some criteria of what is a good response to a student's mistakes. And we came up with these 3 criteria. So first of all, a good response is one that acknowledges the student's efforts or attempt. A good response is one that guides the students towards self-correction. And a good response is when you address the error indirectly, avoiding discouraging language such as mistake or error. And we used another model to rate each response according to these 3 criteria on a scale from 1 to 10. And to get higher quality responses, we used chain of thought prompting and instructed the model to think about its reasoning before giving any score. So this bar chart presents the average pedagogical scores across the different conditions. So the first 5 bars are the ones that I've mentioned previously. So these 5 bars are LLM-generated responses. We have a 6th bar called expert, and this is the pedagogical scores of human expert-generated responses from the original data set. So all of these 6 conditions are responses to the same question, but the first 5 bars are model-generated responses using the different forms of tacit knowledge, and the 6th is the human expert-generated responses. The most interesting finding that I would like to highlight is that variations where conversations were provided during knowledge extraction, so it's the first 2 bars over here, they scored higher than both the human experts' responses as well as the human benchmark, human best effort benchmark responses. So in other words, when we externalize knowledge using large language models, using specific prompting strategies, here it's providing the conversation data, it can generate better responses higher than using the human best effort benchmark, as well as higher than what the human experts are able to come up with. Lastly, the third research question is, can LLM-externalized tacit knowledge support novice learning? So we're interested in using the knowledge we externalized from the first question, transfer it to novices to help them behave more like experts. So this goes back to my motivation of whether we can use LLMs to transfer knowledge between experts and novices within organizations. For our third research question, we conduct an online experiment where we ask participants who represent our novice tutors to generate responses to students' mistakes. And we train these novices using the various tacit knowledge we externalize in the first research question. So this is a screenshot of our testing interface. And as you can see, we have the conversation data ending with the student's mistakes. So the tutor asks, what's the value of 3 to the power of 3? Student makes a mistake by answering 9. And then we have the externalized tacit knowledge that the participants are trained on. And then we ask them to come up with a good response based on the knowledge that you see. And we saw that when the participants were trained on knowledge that was externalized in the LLM plus conversation condition, so as a reminder, this is the condition where we did provide the conversation data, however, did not put any restrictions on the outputs. These participants achieved higher scores than those who were trained on the human best effort benchmark tacit knowledge. And these scores here represent the pedagogical scores, so similar to RQ2. And this is significant because we're showing that when we externalize knowledge using specific prompting strategies, here the baseline plus conversation prompting strategy, novices learn better compared to when they're trained on what humans were able to articulate. So presented a lot of results. So let me actually tie all this together and see what this means. So we looked at RQ1, where we asked what's the best way to externalize tacit knowledge. And the conclusion we drew from RQ1 is that showing the model expert behavior, so showing the model conversation data when externalizing tacit knowledge, led to knowledge that was different from the human articulated knowledge. However, for RQ2 and RQ3, so looking at response generation and knowledge transfer, it was when we used the prompt that showed the model's expert's behavior and a flexible output structure, this prompt was the one that generated the best responses. So I would like to highlight the mismatch between what's the best prompt for knowledge externalization and what's the best prompt for response generation and knowledge transfer. So we think that this mismatch between the best performing prompts for RQ1 and RQ2 and 3 suggests that the model might be picking up nuances of tacit knowledge that is different from what experts are able to articulate. And again, going back to Polanyi's paradox, experts know more than they can tell. We think that this is showing that the model might be picking up things that human experts are having difficulty articulating. So we think that this is a first direction in showing that LLMs might be a practical and scalable solution to externalize and transfer tacit knowledge. And we hope that this is a first step in showing that it can go beyond the field of education, and we can use large language models to help transfer knowledge between experts and novices in different fields. Thank you so much for your attention. I'm happy to take questions.
Hi, thank you for this. It's a really interesting thing I hadn't thought about before this presentation, so I appreciate it. I was curious if you are thinking about doing any repeats of this using a different LLM model. Okay, yeah, that figured. Than ChatGPT, just because I know some of them are trained on vastly different data or have vastly different use cases. So.
Yeah, excellent question. Yes, that is actually one of the next steps that we're thinking of as a robustness check. So we know there are different models. There are cloud models. There are models that think and give a reasoning before they answer. So we're trying to replicate this with the models to see if we get consistent results.
Hi, thank you. This is super interesting. Have you thought of, or are you looking into seeing if there's long-term differences? Like, do the students perform better long-term in their classes in a measurable way with the LLM-created model behavior rather than the expert's articulation?
Thank you for your question. That is actually an excellent suggestion because currently we're only looking at whether tutors can perform better when they were trained on these tacit knowledge. But I guess a longer term research project could be when tutors respond differently, do the students learn differently as a result of their different responses? So I think that is a long-term project, and that would actually show us the more tangible consequences of our research project.
Hello, I have a couple of questions. So when it comes to the knowledge transfer, typically in organizations we have documentations or like knowledge transfer sessions when the person is about to leave the organization. So how does the LLM differ from the typical knowledge transfer sessions, or does it perform any sorts of refinements on top of it?
Yeah, thank you for the question. So I guess just to rephrase your question, you're asking how does the models transfer differ from what happens currently from like within organizations, is that correct? Good question. The main message of our research is that human experts have limited capability of articulating what they already know. So again, going back to experts know more than they can tell, we're arguing that because humans are limited in their ability to articulate their full knowledge base, this is when we need the help of large language models. So when we feed the observed behavior of experts to the model and extract that knowledge is more detailed and more detailed than what experts are able to articulate. And we show that through RQ2 and 3, where we show that it can generate higher quality responses, and it also achieves better knowledge transfer.
This is a question that extrapolates this whole thing. You found a very useful data set that's based on text to be able to demonstrate this, but have you thought about ideas about how to capture knowledge of the tacit knowledge of like art or welding, things that there's only like perhaps video data set rather than text. Have you had thoughts along those lines?
Right, thanks for that question. That is actually one of the discussions that me and my co-authors had a few days ago. So because we're using large language models, which is heavily relying on text data, we were only able to show this in a domain where we had the tutor-student conversations. However, as you said, in art and welding, it's more physical actions, right, rather than the text. And we think that this, not large language models, but we also saw a paper that uses a different deep learning model that actually uses like sensory and like physical like data, as in eye tracking or movement data, and use that knowledge to transfer it between novices and experts for their training. So I think it depends on the medium, whether we use a large language model for text versus some kind of other deep learning model for like physical movements. But they both show that we can use some form of model to help the knowledge transfer between novices and experts.
So consider a RAG implementation. Maybe built about 1.5 years ago, using employees with about 15 years worth of experience. So essentially, the team building this built it for experts. Then they opened it up to the rest of the team. How can we measure, like how would you imagine measuring whether the lack of tacit knowledge in a novice user is changing the way they use the tool? Maybe they're not making the right choices or asking the right questions. And then can something like a RAG solution be used to gather information about what those experts know?
Right. So let me rephrase your question to see whether I understood it correctly. So is your question asking, how do we know whether it's the LLM extracted tacit knowledge that's helping the novices learn better compared to some other form that they've used in the past?
Yeah, that's part of it. I'm a little concerned too that the novices are coming in and not phrasing their questions the right way, or recognizing that a response from the RAG solution is not good enough.
Right. Excellent question. I think that actually is points to a limitation of our research, because we're only using a one-time conversation between a student and a tutor and using that to extract knowledge, as opposed to your suggestion where novices ask questions and we use like a RAG-based system to extract some form of answer. So I guess that is one of the limitations of our study, but if we could have access to that data, I guess it would be a much better research project.
Yeah, so I have one more question. So, yeah, this is. So when it comes to like feeding the LLM models, so if we give use the process of the math experts' responses, so how does the model know how would be the thought process behind the math experts? So do we use the human benchmark data for that to feed the LLM models, or how does that work?
Sure. Yeah, when we externalize the knowledge, there are 3 things we provide. So first of all, the conversation snippet that ends with the student's error. Secondly, math experts' responses to that mistake. And thirdly, novice tutors' responses to that mistake. So we have these three components, and when we're training the model, we provide about 480 of these conversations. And then we tell the model, hey, look at the novice tutors' responses and the experts' tutors' responses, and come up with the thought process that goes behind their minds when experts come up with responses.
Questions? If not, I am going to ask you to give Mina a big round of applause. This was super interesting. Thank you for sharing it with us.